So we're on page 4. Let's look at this top question. This top question has a lot to do with what we did yesterday. Oh, we're going to come back. We're going to bounce around. I know, right? We're going to be on page 4. We're going to bounce around a smidgy. Yeah, what did we do 2 days ago, you guys? What was this? Ooh, so close. We had to eat that outer shell. We had to eat that outer shell, so we left the inner.
And then we ate it.
And then we ate the chocolate. How do I eat that chocolate if the chocolate was G? G prime, right? That's the chain rule right there, you guys. That's what we worked on. We took the derivative of the outer, and maybe you want to remind yourself, oh, F was the outer function, G was the inner function. We took the derivative of the outer, left the inner, times the derivative of the inner. It's like fig, g. But just be careful, because when I say fig plus gif, be careful. That fig means that we're multiplying these together, and this isn't, right? This is f prime of g of x. So just something to keep in mind. You guys, if they want the derivative of this when x is 2, we could plug into my little 2's for x's. Let's go do that. We'd have f prime of g of 2 times g prime of 2. And what would we do first here? G of 2. What is G of 2 from this table right above?
2.
G of 2 is 2. Exactly. She says, so f prime of 2, you're exactly right. And I'm going to even bring over that times. Well, let's go fill this in maybe. What's G prime of 2? G prime of 2 is a negative 3. F prime of 2? 1/3 times a negative 3 gets me a negative 1. So we're back on page 4, number 6. What is my outer shell of number 6? Outer, the 3. So you guys, let's rewrite it. We are doing no calculus yet. We got sine of x squared to the 3rd. That 3 is not very apparent as my exterior, my outer, till we rewrite it like that. You got it, peeps. What is the derivative going to be? What's the first thing? What's the shell? 3. Leave it. Chloe, what's my exponent going to be?
Squared.
Boom. We've just eaten the shell. We left the peanut and the chocolate there. We did one derivative at a time. What do you multiply that by? What's my new outer and my inner? Yes, agreed. She says, okay, I'm going to eat this chocolate, leave the peanut of my x squared. Then I'm going to eat the peanut. Boom. It's often harder to figure out what answer this matches to. You know what I'm saying, people? Careful, everything's being multiplied. Need a 6x. So I like that 6x. I like that 6x.
It's either C or E.
Agreed. He says, I think it's E. What'd they do right here? Can we just bring that in?
Yeah.
Yeah, it's equivalent, you guys. Meister, why do you think textbooks... Yeah, that's right. Oh, Meisters. All right, so sorry. We said that this one was E for surezies. Good job, good job. Let's go try the next one. I'm going to have you guys try that. I'm going to give you 90 seconds. Talk to me about what I can multiply together here. Can I multiply 2 times 3? And a negative 1. Negative 1 times 2 times 3 gets me a negative 6. And do I have a cosine and a sine left? Yeah. Okay. We're going to be talking about something called the chain rule. You're like, the chain rule? What the heck? What's the chain rule? All the chain rule's talking about is how we would take a derivative if we have a composite function. You're like, okay, composite, what is that even talking about? A composite function just means that there's a function within another function. So it's a function in a function. That's what makes something composite. F of g of x. G of x is in f, okay? So, which of these would you say represents a composite function? We're just brainstorming here, you guys. There ain't no shame. Which one is a function within a function, might we say? Any guesses? You're saying G. And why did I not tab here? I'm very sad at myself. I don't know. G is totally a function within a function. So you guys, let's just circle it. And anyone have any ideas which one would be the outer versus the inner function? Again, we're brainstorming. No one's seen this before.
X squared is inner.
Yeah, the x squared is on the inside and the sign is on the outside. Very good. I think it's just going to be helpful to write that as we start seeing these. Why do you think I got an M&M if I'm talking about an outer and an inner?
Something inside.
Yeah, what's on the outside?
Just a shell.
It's a little hard candy shell, which is delicious if you ask me. What's another one that has an outer and an inner by chance? Top right. This one is, and this one's a little funky. This one is going to be my outer, my 3, and then my exponent's going to be my inner, which is a little funky. And you might be like, but that's kind of on the outside. I hear you. I'll explain as I've got that x in the exponent why that one's my outer. There's one more.
Is it FX equals X or the bottom right?
So bottom right is 3x, 3 times x times e to the x.
I believe it's f of x, no?
This one again is x times the sine of x.
What makes it a function in a function versus being multiplied?
Yeah. Let me show you. It is this one. What would be my outer function? The thing to the 4th power. Exactly. This is my outer function right there. Good, you guys. We're just brainstorming. This x plus 5x is the inner.
Is it if it has an exponent or something? What makes it out versus in?
Let's, like this guy here, why isn't this a function within a function? Can we just take the derivative of this guy? 3x squared. So that is just one function. Can we take the derivative of that guy? Yeah. So we haven't had anything this complex yet, if you will. Okay. Over here, we can do product rule to multiply 3x times e to the x is not as complex, meaning the derivative of this inner thing is no longer 1. Up until today, the derivative of, say, this exponent was always 1. The derivative, if I gave you, hey, the derivative of sine of x, what's the derivative of that? Cosine of x, because if we thought about x as my inner, which it technically is, what's the derivative of that inner? 1, and it wouldn't affect anything. So up until today, my inner function always had a derivative of 1, and now my inner function's not going to have a derivative of 1. We're going to start applying this chain rule. So again, I brought M&Ms because, again, we have some outer and inner function, a shell and some chocolate, if you will, right? So before I pass them out, let's just real fast. We agree, we saw this above, that this was the outer and this was the inner. What about this one over here? How can I rewrite that as an exponent?
1/3.
Yeah, wait, isn't this the same as h of x to the, it always goes power over root? So it'd be to the... One third would just be the original. This is the cube root of something is the same as something to the 1/3, and we don't have to worry about taking that derivative yet. Here's what I want us to see, and then we're going to get some chocolate on our hands. You guys, if something's given to us like this, which one of these is the outer and the inner? F is the outer. You guys go ahead and put that. Boom. F is the outer. What's G? That's the inner. How do I apply this chain rule? What are they telling us to do? Take the derivative of the outer. Eat the shell of your M&M. Then what do you do with the chocolate when you're eating the shell? You leave it. That's perfect. We are going to have to work on today how to eat an M&M, just the shell. Leave that chocolate. Then what do we multiply by? The derivative of that inner, the derivative of the chocolate. Let's try it. Okay. So as you enjoy your M&M, one shell at a time. You eat the outer shell. That's the derivative of the outer. You leave the chocolate as you eat the shell. Then you multiply it by the derivative of the chocolate. You're finally going to enjoy that chocolate, okay? So now I want to tell you why we love, actually no, let's practice it, then I'm going to tell you why we're grateful for the chain rule. Right here, we've seen this problem 3 times. This is the outer. This is the inner. How would I take the derivative of the shell first? How would I eat the shell? What's the derivative of something to the 4th power? 4 blank to the 3rd. That's the derivative of the outer, right? That right there is my f prime. What am I supposed to do with my g, which is that chocolate?
Leave it.
I just leave it. What stays in there? X cubed plus 5x. What then do we have to multiply by? When you're eating your M&M, you do want to enjoy the chocolate at some point. Derivative of that inner. She says 3x squared plus.
5.
Done.
Let's go.
Do you need to take it any further? Absolutely not. What a gift, right? Prior to the chain rule, you want to know how we'd have to take this derivative?
Something miserable.
Let's think back in algebra. I'd have to take x cubed plus 5x to the 4th by hand. Then, after all of that, we've done no calculus. I'd have to go take the derivative of everything by itself. Would it be equivalent to this? Yeah. Is this so much easier? Thank goodness for the chain rule is all I'm saying. Okay? Let's go over here. Let's go over here. Graham Nellis, how am I going to say this again? This is the same as h of x to the, you know it. That's just my algebra skills. You guys, we got to eat the shell first. What's the derivative of my outer? Where's that 1/3 go?
Blank.
1/3 blank to the. 1/3 minus 1 would be 1/3 minus 3/3. Is negative 2/3. What did I do with that inner, that chocolate when I ate the shell? You leave it. Then what do I do with that chocolate?
Prime it, yo.
I prime it. I eat it by saying multiply that by h prime. Deal? This is the chain rule, people. I like the chain rule because we get M&Ms. Whew. Okay, E is a little difficult. Okay, I really wish I didn't start with this one because this one's hard in my opinion. But we can do it. You guys, we still love E. I still love E. What's the derivative of E to anything? You know it. But the chain rule says we still got to take the derivative of that exponent.
3.
Yeah. That's my answer now. Why did I never have to worry about that before? Because it was always an x. The derivative of x was 1. So let me say this one more time. Whoops. This is E. Yep, real fast. This guy was my outer.
Yeah.
This guy was my inner. The derivative of e to the anything is still, we still love e to the anything, times, we left my x, we left my g, right? My inner. And then we got to multiply by the derivative of that inner.
So it would be e times 3x.
E to the 3x times 3.
Okay.
Yep.
I see.
And then I just threw that
I just thought
3
we
out
could
front.
bring-
This is hard. Which one do you think is my outer? Yeah, this is my outer. You guys, let's go back to just, what if I just said ln of x? What's y prime? It's 1 over x because that's here.
Wouldn't it just be 1 then?
Careful, times the derivative of that.
1 over 1.
Okay, so this guy, now we're going over here, I feel like. The derivative natural log is 1 over this every time. Because, bless you,
Bless you.
this was my inner, and we don't get to touch the inner, right? You just ate the shell, and we did that. Do we need to multiply by the derivative of the inner?
5.
Yeah, which is 5. Could I say my final answer is 5 over 5x plus 1?
Yes.
Yeah, don't have to. Do you agree, bless you? We've only been taking one derivative at a time. We did 1 over this. And then you're going to multiply by another derivative. That's how that chain rule is working. We can't do it all in one step, okay? One derivative at a time, one layer of your M&M at a time. Okay, let's try this guy. We love E. Derivative E, leave it. E to the side of x minus 3x. We leave it. But we do need to multiply that by what? The derivative of g. Cosine of x minus 3. If I left out parentheses and I went like this, is that equivalent? No. Problem. We got a problem. Here we go. Ooh. Ooh. 1 over the thing in the parentheses every time times the derivative of the things in the parentheses. So close, Bo. So close. Sine over cosine gets me tangent. It is cotangent. Oh, you don't have to apologize. He says sorry. Okay, we're going to skip 5 for Thursday. Let's go to 6.
That's lame. Just do 5.
Secant.
Secant.
Which one's my outer?
Secant.
This one's my outer. Let's go in a prettier pink here. This is my inner. The derivative of secant is secant tangent. What am I going to do with that 2x if that's my inner? It becomes secant of, careful, we can only do one derivative at a time. So okay, let me back this up. If my function was secant of x, and I said the derivative is secant x tangent x.
Secant 2x tangent.
Agreed. He's saying, wait, I got to leave my outer, derivative of my outer, which is secant tangent, leave the inner. The angle stays. Yes, this right here is the derivative of the outer. You left the inner. We still need to multiply this by the derivative of the inner. 2. Could I put that 2 here?
Yes.
Could I put it here?
Yes.
Could I make it this?
No.
No, can't mess with the angle, okay, guys? But you could make it, I'm going to make it a coefficient. So we're on page 1. We left one question undone. We left one of them. And why did I leave this one? You guys, we got to think just back, basic algebra. What is this to the third power here? What does that really mean? Basic algebra, no calculus involved. Oh, beautiful, you guys. I would absolutely rewrite that every time you see it, because what it really pronounces is what's the outer function? The 3. Did it look like it was on the outside up here? No. Not really, right? So this is no calculus involved. This is just really to help us see, oh gosh, that's my outer. What's my inner? This whole thing, which yesterday we didn't see anything with I just wrote sine. We didn't see anything with an inner this big, but that's okay. What did we do yesterday? What do we always eat first on our M&M? My outer.
Sine of 7x.
3, leave that chocolate to what power? Good. So we took the derivative of the outer. We left the inner. That's what we've done so far. We've eaten the shell. Why is today a peanut M&M? What do I have in here? This is my quote-unquote inner, but what do I have really in here? Don't I have another outer and an inner? I hear you. We can grimace at this. Gross. This is another outer and a new inner. That's why we got a peanut M&M today. I really have 3 layers. You get to take one derivative at a time. We are going to eat 1 layer of this peanut M&M at a time. You ate the shell here. You left the inner. Now I've got to take the derivative of this inner. The derivative of sine gets me a cosine. Leave the peanut. Leave the 7x. 1 derivative at a time. So we took the derivative of the outer. We left its inner. Now times the derivative of the inner. 7. That's my final answer. Whew. This is why we're going to have peanut M&M. You guys, could I rewrite this as 21? Sine of 7. Ooh, watch it. Watch how I'm going to write this. 21 sine squared of 7x. Cosine of 7x. Could I write it that way? Yeah, this is how their answer would be. It's -3. Let's go to page 3, you guys. Okay, this is gonna be the last one that we do. Look what they want. This has been a theme, right? Equation of a tangent line. They're gonna ask it definitely on the AP test. Guys, that goes back to that point slope form. Every time. What do we need for point slope form?
We need a point to slope.
A point to slope every time. Which one do we want to start with? I don't care. We want to start with slope, which we know is the derivative. True, but if we were given k of x is this, we got to go take that derivative, right? All right, let's start with that slope. I dig it. Do you guys agree of my k, I've got an outer and an inner?
So K of 3.
K prime of 3. Eat the candy shell. f prime of g of 3. You took the derivative of the outer, you left the inner, times g prime of 3. You guys literally make my heart go pitter-patter. This is so good. What are we starting with? We could do either. Let's start just left to right. G of 3, I'm going to zoom this out. G of 3.
6.
G of 3 is 6. So do you agree we have f prime of 6?
Yes.
Times, to your point, Stevie, we need what? Good, which is? Good.
10.
So therefore, f prime of 6 is 5 times 2 is 10. What did we just find? My slope. Awesome, you guys. For point slope form, we still need a point. Do we have the x-coordinate? Love it. How would I find the y of my function?
Plug in 3.
Plug in 3, right? I need to know what k of 3 is. K of 3, right? Because we're writing the equation line of k, which is f of g of 3. No, that's a good call. We only do chain rule when we're taking a derivative. That's a great question, Colin. Right here, we just need k of 3, which is f of g of 3. G of 3, what do we got?
6.
Oh, again. And then we need f of 6. So what's my point? Write it as an x comma y. 3, 4. You guys, we have a point now and a slope?
Yes.
Help me out. What's my point slope form? You guys. Unbelievable. Thank you. That's it. Here's what I want you to do. Your homework is now in the packet. I want you to try pages 2 and 3. 2 pages. Pages 2 and 3. Steve, are you listening? Pages 2 and 3. I'm going to put the answer key up. You won't be able to see it great because it's going to be a little zoomed out. Do you have access to the answer key? Always. Let's brainstorm. We're on the top of page 5.
And the chain rule.
Close. The what rule? Say it again.
That's what I meant to say. Product.
Exactly. Dice and Greer are saying product rule. Fig plus GIF.
And the use of chain.
And the chain rule within my G prime. Oh my gosh. So Greer just guessed it is D. Now we got to go work. We got to work backwards and prove Y is D. Here we go. You guys, do you recognize that we have one function times another function? Okay, we got one function times another function. Yeah. So you're like, okay, I'm just going to start with what I know. One is product rule. What do we have to start with? F prime, right? What's the derivative of the first? We're going to just take this one little chomp at a time. Derivative of the first one? 1. You're like, cool, I just did F prime. We need to multiply that by G. What's my G? You guys, we're halfway done with the product rule. We've already got our fig. Let's go. Plus, this is where it just takes a little longer. We got to do G prime. Okay, we got this. Let's look at our G. Of my G, do I have an outer and an inner?
3.
Yeah, so we got an outer 3 and an inner. Okay. The derivative of my outer, Graham and Soph, you said bring that 3 out front. What do I put in the parentheses? Leave the chocolate. Thank you so much. Perfect. Exactly. That's the derivative of the outer. You left the inner. What's the derivative of the inner now? 2x, right? That's what we got to multiply it by. Did we just find G prime? Yeah. Yeah, times my f. You guys, did you do that?
It wasn't that bad.
Teamwork makes the dream work.
Here's the problem. Does that match one of these answers? That's annoying, right? Here's what I feel good about, you guys. You did the calculus of it. You just did the calculus. Whew. This is annoying because this is all algebra. And you agree, you're like, where does it get 7x squared? We're going to get there, but that's where we are right now. Here's what I say. Before we distribute and do all these things, can we maybe simplify this? Like, do I really need a 1 times? Let's just simplify a smidge. So do you agree we got x squared plus 2 cubed? And Could I multiply my 3 and my 2x?
Yeah.
So we'd have a 6x. And then I still have an x squared plus 2 squared. Whoa. And an x minus 1. Graham called it. The answer was D. But I don't see, again, a 7x squared. Like, what? Where do you think this came from?
Leave the one on the right.
So you're saying there's an x squared plus 2 squared over here. What about over here?
There is. So but it's huge.
True. So they both have one.
Oh, you just write one more and then you have.
Could I factor that x squared plus 2 to the second out?
Everything
Oh.
else by one.
So that's what they've done. They said, oh, they both have an x squared plus 2 to the second. So I'm going to factor that out.
Okay.
Right? And again, here's what I'm worried about. You did the calculus and you stayed with me. I appreciate it. This is just straight up algebra. So let's see how we do. X squared plus 2 to the second times what gets me x squared plus 2 to the third? X squared plus 2. When I factor this out from the right side, what's left?
6 whole minus 6.
Just a 6x, isn't it? Right?
Can you just, yeah.
Wouldn't I just have this 6x to bring down there and that x minus? Oh, I got you. You already distributed it? I'm down with that. No, I'm down with that. Soph's is just like, why aren't we just distributing to save ourselves a step? This is already the longest problem of my life. She's just saying, all right, this is going to distribute here to get me a 6x squared minus a 6x.
Yep.
Okay, Graham Nels, why are we digging that?
Wait, these aren't.
Oh, there's a 7x.
Where talk to me, Aiden.
6x squared plus x squared.
6x squared plus 1x squared gets me 7x squareds. Write it in
6x.
descending order.
Plus 2.
Wow is right.
I guess D.
We just have to correct the tuition.
Now, on the AP test, are you going to just guess on some problems?
Yep.
Sure.
Always.
Sure.
This one.
We're not going to leave any of them blank because you're going to be wrong no matter what, right? You're going to guess. Here's my frustrating part on this one. You did the calculus. Why did they have to put so much algebra? You know what I'm saying? But we did it.